Once again, it's time for physics with Mr. Anderson. We're going to look at problem number 16 from problem set 1.12, projectiles. The skier leaves a ramp at an angle of 16 degrees with the horizontal and lands 100 meters away, we'll investigate that, along a hill sloping at a 37-degree angle. How fast was the skier going if he left the ramp at a height of 4 meters from the ground? All right. Let's first just unpack this diagram. There's a lot going on. We're given this value 100 meters away, but that's along this line right here. This is a 3, 4, 5 triangle, which is nice. 37 degrees. When you see 37 degrees, know that that's referring to a 3, 4, 5 triangle. So if we make this triangle right here, being a 3, 4, 5, if this is 100, then this would be 80 meters, and this is going to be 60 meters. So the actual height above the landing point is going to be 60 meters plus this additional 4 meters. So the displacement in the y direction is actually going to be negative 64 meters. The displacement in the x direction is 80 meters. So I'm going to just write some things down that I know. In the x direction, in the y direction, displacement in the x direction is 80 meters. Displacement in the y direction is negative 64 meters. Given that the angle is 16 degrees, and that's about it. So from this point, I really got to start digging in. One clue that a system of equations will be necessary is the fact that we are given neither an original velocity nor a time. If both of those are absent, then we really don't know enough to get off the ground. Literally, we don't know very much at all other than some limiting parameters of this thing. And so that's kind of a clue that we're going to be in for a system of equations. So with that in mind, and here's a what do you do when you don't know what to do situation, just start generating some formulas and see if you can plug some things in. So in the x direction, really the only formula available is that the displacement in the x direction is the velocity in the x direction times time. Of course, without velocity or time, two unknowns, there's a clue. We're going to need two equations. In the y direction, displacement in the y direction is VOY times t plus, well, I'm going to jump right ahead, plus 1/2 acceleration, but half the acceleration is half of 10, so that's minus 5t squared. So there's my y equation. In the x direction, my velocity in the x direction is going to be original velocity times the cosine of 16. All right, so at least I know an angle. I've got something. And my original y velocity is going to be the original velocity times the sine of 16. So I've got a couple expressions that I can work with. So that tells me that my velocity in the x direction is going to be 0.96 times the original velocity, and the original velocity in the y direction is going to be 0.275 times the original velocity. So in the x direction, I can say that my displacement in the x direction, 80, equals 0.96 velocity times t, and in the y direction, my displacement, negative 64, equals 0.275 v times t minus 5t squared. So I've got v and t in both of these equations, and this is the point where I'm just about ready to plug one into the other. Of course, I need to solve for one in order to plug it into the other. I'm going to solve for t. So 80 over 0.96 v equals t. So that gives me 83.3 over v. That is my expression for t. I'm going to sub that in over here. Negative 64 equals 0.275 v times t, which is 83.3 over v, minus 5 t squared. 83.3 over v quantity squared. Now I'll expand that. I've got negative 64 equals, the v's cancel, 0.275 times 83.3 minus 5 times 83.3 squared times 1 over v squared. So this is actually getting a little bit simpler. I only have one variable in this entire expression. So that gets me negative 64 equals 22.92 minus 34,694 over v squared. So I'll subtract this from both sides. And that gives me, make some room here. That gives me negative 86.92 equals negative 34,694 over times 1 over v squared. I'll multiply both sides by v squared and then divide both sides by negative 86.92. And that gives me v squared equals 399, and v equals approximately 20 meters per second.